Today we are diving into enolates, which unfortunately is the hardest topic in all of O Chem, in my opinion. This is the hardest topic in O Chem 1 and 2. This unit is very, very important. So I'm going to start this video by giving you a disclaimer or a warning or a heads up that this unit requires you to be on point with everything that you have learned in this class up until this point. It requires you to be super consistent, and it requires you to know all of the tricks forwards and backwards, and to really understand what's going on in context of everything you've learned up until this point, which makes it very, very difficult to manage when you encounter it in a test scenario. What I'm going to say is the good news is that you're going to see a lot of tricks in the videos to follow. You're going to get a lot of insight of the easiest way to access this material, which usually drives everybody nuts when they first encounter it in O Chem 2. And so, as long as you keep the trick straight and as long as you know where you're at, this section is going to be manageable. But please, be consistent. Make sure that you really understand what is going on before you move forward, and you'll be good. Okay, so since we're talking about the big picture here, I want to give you guys a recap of everything that you've learned up until this point in O Chem 2. Okay, and so what you've learned up until this point in O Chem 2 is you had an aldehydes and a ketones unit, and then you had a carboxylic acid derivatives unit, which I call the ladder. And so the thing that I want to remind all of you about is when aldehydes and ketones interact with nucleophiles, well, what you've learned is that nucleophiles go straight for the C double bond O. Okay, so that's not going to take you by surprise. And the consequence of that in the aldehydes and ketones unit, for the most part, is you get something that looks along these lines right here. Not every single time, but when a nucleophile attacks an aldehyde or ketone, you get something that looks like these right here. And the reason why, like we've talked about before, is because aldehydes and ketones do not have a leaving group. So since there's no leaving group, you can't kick anything out. So the consequence of these reactions is usually something that looks like this or a variation of that. Now, if we look at the carboxylic acid derivative section, you have a leaving group on all of these molecules here. So I'm just going to draw a box around all the leaving groups and everything in the carboxylic acid derivatives section. And so since these molecules have a leaving group, you know that the nucleophile still attacks the C double bond O, but you are going to kick the leaving group out. And notice what I did right there is mechanistically garbage. It's a trick. The nucleophile in the carboxylic acid derivative section, it comes in, it kicks the leaving group out, and the leaving group ends up gaining hydrogen, and the nucleophile loses hydrogen. And so up until this point, you have kept these two sets of functional groups right here completely separate. Now, in the enolates chapter, what makes this very, very, very tricky at the outset, and it makes it very tricky after you've learned everything, and we're going to talk about that at the very end recap of this entire video series, is this unit makes aldehydes, ketones, and esters have something in common. So this is a little weird because up until this point, you've kept aldehydes and ketones completely separate from esters by the fact that aldehydes and ketones have no leaving group and esters have a leaving group. And so in this enolate section, the thing that I want you to remember at the very, very outset, the thing that makes aldehydes, ketones, and esters have something in common is that all three of them have acidic alpha hydrogens. Okay? That is the thing that this entire unit hinges upon. So the alpha carbon is always the carbon that is next door to the C double bond O. So I'm designating that here on these groups. So it's always the carbon that is next door to the C double bond O. And in this unit, the hydrogens hanging off of the alpha carbon are acidic on aldehydes, ketones, and esters. And so what I want you to notice here at the outset, in the first unit, we were using nucleophiles. In the second unit, we were using nucleophiles. But here in this unit, the thing that makes this unit completely separate from the two that you already know is you are going to be adding a strong base. Okay, so a strong base because the alpha hydrogens are acidic. And so remember, this is my favorite phrase. What do bases love? Bases love hydrogen. And based on what you know right now, the acidic hydrogens are at the alpha position. And so what you are going to be doing in this unit is if you add a strong base, that strong base is going to rip off those acidic alpha hydrogens, and you are going to make what is called an enolate. So I'm going to draw those here for you right now. So these are the enolates that you generate in this unit when you add a strong base. So these right here are enolates, and they're the things that are going to be driving all of the reactions to follow. Okay, and so I'm going to go on a little mini rant because professors are picky, and they decide to be picky about very stupid things. And this is one of them. So from here on out, I'm going to be drawing enolates like this right here. Okay? Your professor more than likely will say that there is a correct way to draw the enolate, which is ridiculous, but bear with me. So all of these enolates have a resonance structure, okay, where you could push that negative charge in and kick that double bond up. So technically, the correct way to draw an enolate in all of these cases looks like this right here. So some professors don't care, and I love those professors, but very often professors will be very nitpicky about this, and they'll want you to draw your enolates like this. I have a problem with it only because when you are first learning it, the correct way to draw an enolate doesn't show you where it's reacted. And so at the end of the day, what I want you to know is that enolates are nucleophilic at their alpha carbon. And so that's why in all the videos to follow, I am going to draw the enolates like this, because it gives your brain a clue as to where these are nucleophilic. There's a negative charge on the alpha carbon. Okay? So, in summary, you have just entered into the hardest unit in O Chem. All of O Chem, O Chem 1 and O Chem 2. Take your time with these videos. Really absorb the tricks, practice the tricks, come back to the videos. But at the end of this, we are going to come back to these 3 units here that we just talked about, because keeping them separate is the key to doing well on the test. So great work bearing with me on this. I know you're probably a little nervous after hearing the news about this unit, but trust that the tricks will carry you, and as long as you are consistent, you're going to be in good shape. All right, I'll see you in the next video.